Okay, did anybody walk in while I was playing around with the Zoom? So Kaya and Lauren? Victoria, okay, I was confused because okay, so we're doing chapter 5, okay, I think it is. We're starting an introduction on the flow of food. Chapter 4, I'm sorry, my source PowerPoints are numbered differently. So when we talk about the flow of food, talking about the path as it goes through our operation. So it starts up here with purchasing. We get our food from approved reputable suppliers. We receive it. We store the food. Goes to the kitchen for prep. It gets cooked. It might be held. It might be cooled down and held in the refrigerator. And then if that's the case, we would reheat it. Or it could go straight from cooking to service. So we're going to talk about keeping food safe through all those steps. And the two main things that we can do while we're doing that is prevent cross-contamination and time temperature abuse. So one of the things we can do to prevent cross-contamination is use different equipment for different items in the kitchen. You have separate equipment for raw and ready-to-eat food, and we've got the different colors for the cutting boards. The yellow would be for raw poultry. We've got red, which is for raw meat. We've got green for produce. We've got brown for cooked meats. You don't have to know those right now. Whenever you get to the lab tool, you'll get familiar with those. The other thing is make sure we're always cleaning and sanitizing all the work surfaces, all the equipment that we use, utensils before and after each task. So we're not going to cross-contaminate that way. As much as possible, prep raw and ready-to-eat foods at different times. So if you have a very small kitchen and you have to use the same prep table, definitely you would be doing your raw meat seafood before, or not before, but at a different time than you would do ready-to-eat food. And whenever possible, you do the ready-to-eat food first, get it put away, and then work with something like your meat, fish, poultry. Okay, so we already talked about that part. Another thing that you can do is buy food that's already partially or fully prepared. Depending on the type of operation you have, you might be able to buy pre-cooked chicken and use that on your menu, where all you might have to do is heat and serve it, or slice it up and put it onto a salad and serve it. Or the bags of the different salad greens that are very popular now. And temperature danger zone, I think we talked about this before, 41 degrees to 135. So when we keep food in the cooler, we have to check on a regular basis that the cooler stays below 41 degrees. And then once we cook food, we have to make sure that we're holding it at a temperature 135 or higher. If it's between those two temperatures, then it's being time and temperature abuse. Also, if it's cooked to the wrong internal temperature. So does anybody know the minimum temperature for cooking chicken? 165, okay. So you have to cook all chicken, all poultry to 165 degrees. So if you fail to do that and you fail to check it, then you use temperature abuse for chicken. If it's held at the wrong temperature. So if you cook it and then you just put it on a rack and let it sit there until somebody orders it, that's not going to work. You have to put it into either a hot, a piece of equipment that's going to keep it hot, or cool it off to refrigerator temperatures. If it's reheated incorrectly, and we'll cover all of the steps in reheating at a later date. Most of our pathogens grow faster between 70 degrees and 125 degrees. So that's exactly the temperature range in almost every kitchen that you're ever going to see. We have to control how much time the TCS food is sitting at those temperatures. So we're avoiding, yes. Okay, start that again. I know you're talking about a rare medium rare steak.
You know how most people cook it to a lower temperature. You have to worry more about time.
That's exactly how I want to answer this. With something like a steak, like we talked about earlier, we said that you can, you're killing the bacteria because it's on the surface, and as long as you don't do something like jab it into the steak while it's raw, you're not going to be introducing that bacteria into the interior of the steak. As far as people have different ways of preparing a steak. Some people will take it out of the freezer and put it right onto the grill. Some people will let it sit out at room temperature for a short while and put it on the grill from there. But it's up to like the chef. You're going to cook it to the temp, whether it's rare, medium, or medium well. So did I answer your question? I'm not sure. Okay. All right. So when we're working with TCS food, we want to monitor time and temperature, keep track of how long we keep TCS foods in the temperature danger zone. We have to make sure we have the correct kinds of thermometers. Regularly record temperatures and the times that they are taken. Minimize time that food spends in the temperature danger zone. So avoid letting things just sit at room temperature. Take corrective actions if time temperature standards are not met. If you have a buffet, you've got two different soups out on the buffet. If it goes into the temperature danger zone and it's been there for 4 hours, and you only check every 4 hours, you're going to have to throw that soup away. But if you check it every 2 hours and it's 120 degrees, you can take it back into the kitchen and reheat it, bring it back up above 135, and it will be okay to serve. Okay, so the most common thermometer that you're going to see is called a bimetallic stemmed thermometer. Does anybody have one of these? Okay. So it measures temperature through this long metal stem over here. And the actual sensing area starts at a dimple that's a couple of inches from the bottom. So that whole area of the stem has to be inserted into the item that you're taking the temperature. At the top of it, it has a calibration nut. And you're going to use that to maintain accuracy of your thermometer. what they don't show you here, we'll see later, is that it comes with a case. Usually the case has a little holder on it that is the exact size of that calibration nut. So you can just suspend the thermometer in there and adjust it to a correct temperature. Okay, other types of thermometers, thermocouples and thermistors. It's a digital device, runs off of a battery. It measures temperature through several different types of metal probes. The sensing area is at the tip of the probe, and it's got 4 different interchangeable probes. So the immersion probe, you really can't see the probe, but it looks very much like the probe on the regular thermometer. And it's used for measuring the temperature of liquids. So that's what's in the photograph that you see now, is an immersion probe. If you can see the little numbers here, it's reading 32 degrees. This is an air probe. You can see it's got the little measuring devices on here. You'd typically be checking temperature inside a cooler to see what the temperature is there with an air probe. And then the last one I have is a surface probe. And it's got a little bit different type of a tip to it, where you would put it right onto a griddle or a grill to find out what the surface temperature is. And then the penetration probe is just like the instant read thermometer, the bimetallic stem thermometer. We also have laser thermometers, infrared. Did y'all have temperature checks in high school during COVID? Okay, so that was an infrared thermometer usually, unless you had a really high-tech camera. With these infrared thermometers, you hold it as close to the food or the equipment as possible. It's going to, again, give you surface temperatures. So you want to move anything between the thermometer, the food packaging, or the equipment whenever you're taking temperature. And each manufacturer is going to have different guidelines. Something else that we have is called a maximum registering thermometer. It indicates the highest temperature reached during use. So we use it in places like a dishwasher where we can't hold a thermometer inside a dishwasher and it's going to record the highest temp. So it shows in the photograph, this is a rack of dishes that's coming on the outside of the dishwasher. The temperature is reading 194 degrees. So some dishwashers don't use chemicals to sanitize, they use hot water. And we're going to learn the temperatures that that water has to be. 194 is way above what you need it to be. We also have time temperature indicators, the sticker that goes onto packages by your suppliers. If that product is time temperature of use, if it's supposed to come in a refrigerated truck and refrigeration breaks, then we're going to see, there's a little button to make it, to activate it. It tells you that it's on. And then if it's in the temperature danger zone, it goes above the 41 degrees, it's going to turn colors. So you're going to know that it's been abused for over 4 hours. Okay, so calibrating thermometers, and this is just adjusting them so that you get a correct reading. We have 2 methods. We have the ice point method and the boiling point method, because we know what temperature ice should be, and we know what temperature that boiling water should be. So So the first one they're going to show you is the boiling point method. Take plain tap water and bring it to a boil. The disadvantage to this is that you have to hold your thermometer over boiling water. So as in the photograph here, this person's wearing insulated gloves in order to do this. You put the thermometer stem into the water, and you can see the red, that's actually the case for the thermometer that's holding the thermometer in place. And then while it's in the boiling water, you can turn it so that it reads 212 degrees, which is normal boiling point unless you're at higher elevations, and then the boiling point goes down. Okay, the ice point method. This is a little bit of show and tell here. So this is a container of ice. This is a container of water. So this is filled all the way with ice. That's how we make ice water, is fill it up with ice, and then you add the water so that it's to the top of the ice. And then I don't have a analog thermometer, I just have a digital one. So it has an on-off button on it. Oh, that's not gonna work. Oh, I'm sorry, I didn't check the battery on it. The battery's dead. But if I were going to use it, I'd stick it in here, maybe 15 to 30 seconds. And then it doesn't have the calibration nut because it's a digital thermometer, but it does have a button on it that you press to calibrate, and it will set it at 32 degrees. So sometimes we call these instant read thermometers, but they're anything but instant. It's going to take up to half a minute for it to reflect the actual temperature. General guidelines. You want to wash, rinse, sanitize, and air dry these things before and after you use them. The last thing you want to do is contaminate the stem. Stick this into partially cooked chicken and then just shove it right back into here, because then you're going to have the bacteria inside of the case, and you're not going to be able to clean and sanitize that case. You're going to calibrate the thermometer very often after they have been bumped or dropped. If they've been exposed to extreme temperature changes. So if you do something like check the temperature of ice water and then check the temperature of boiling water, that's close to a 200-degree change in temperature. So that will also cause it to go out of calibration. You want to have them calibrated before deliveries arrive so that you can take the temperature of products when they're being delivered. And also before each shift. So this isn't like you have a thermometer and it's going to stay calibrated forever. It's kind of a daily thing as long as you don't pump it. Okay. So when we use thermometers, we make sure they're accurate. And we do that by specifying when we buy the thermometers what type we need. So if we're using a thermometer to check food, it has to be accurate within 2 degrees plus or minus in Fahrenheit. If we're using it to check air temperatures, then it can be plus or minus 3 degrees. only use glass thermometers if they are enclosed in a shatterproof casing. The last thing you want is glass shattering in your kitchen. Anybody know why you would use a glass thermometer? Candy making, yeah. So when you're boiling sugar, the best thermometer to use is a candy thermometer, and usually have glass in them. Okay. So if it's a solid item that you're checking, you insert the thermometer stem of the probe into the thickest part of the food. A lot of times you'll have a roast and it's not perfectly shaped. So you want to go toward the thicker end because that's where the temperature will be lowest. Take more than one reading in different spots, especially in the larger items. And then wait for the thermometer reading to steady. So none of you have worked at the Masters Golf Tournament in Augusta, correct? Is anybody aware of that golf tournament? Okay, it happens the first weekend in April every year. It's a very large event. And for probably about 4 years, we've been sending students to Augusta National, sends a bus over here and haul students over there to work during the tournament. And they serve a lot of people, a lot of food. And they have kitchen health inspections every day. It costs a lot of money to be able to go and attend these events. And they check the temperature of every single burger that goes out. And they've got all kinds of different things, a lot of wild game. So they have like elk burgers and buffalo burgers and regular hamburgers, turkey burgers. So they're making sure that every single one is checked and double checked. And they've got the money to hire enough people to do all of that kind of thing. So this is the last slide on this presentation. Are there any questions? Okay. Have you all heard that there's a storm in the Gulf? Okay, let me turn off the